Welcome back, guys. Today I'll be doing function transformations. Translation will be done along with reflection of the graph, and we will be seeing the stretches horizontal, vertically, along with the compression. Finally, you'll also see the modulus of a function. Let's get started. Function transformation is similar to transformation in geometry, and this is where we can move the graph along with resizing the graph. Say, for example, I have the translation y equal f of x plus a. If this is positive, then it means that we're going to move upwards. And if this is negative, then we will move the graph downwards. So in other words, we can move the curve up by adding a units or down by subtracting a units. So I'm hoping you're realizing that the y values are being affected. Here, this is f of x. From previous activities that I have done, and maybe you have done in your class, f of x represents y. So we're either adding a units to y or we're subtracting a units to y. So in other words, this dotted line represents the function x squared. So if I am adding a units, it means that the entire graph, this curly bracket is denoting that the entire graph will be shift a units upwards. So this will now be our new function f of x plus a. So if a is 3, then it means I'll be shifting 3 units upwards on the y-axis. But if a was minus 3, then I'll be shifting 3 units downwards on the y-axis. If I have translation y equal f of x plus a, x plus a within, there's a change in the x values. So if you realize the x is being affected. So if I add a, then what's happening is that we're shifting a units to the left. If I add 3 units, then I'm going to shift 3 units to the left. If I subtract 3, so I have x minus 3, then I shift 3 units to the right. So the graph will be on my right. So in other words, we can move the curve to the left by adding a units or to the right by subtracting a units. And as stated before, the x values are affected. So here we're shifted a units to the left if we're adding, and a units to the right if we're subtracting. Vertical stretch or compression y equal a times f of x. Now a is a constant and f of x represents the y value. So it's the y value that is being affected. Now if a is greater than 1, we have the curve vertically stretches. If a is between 0 and 1, that is a is greater than 0 but less than 1, the curve vertically compresses. So in this instance, this green curve represents y equal x squared. If I multiply this by 2, then what happened is that I'm multiplying f of x, which is the x squared, by 2. And since 2 is greater than 1, I am expecting a vertical stretch. Now, the vertical stretch occurs when the graph is multiplied by a number greater than 1. In this case, it is 2. So this results in the graph pulled, but retaining the input values, meaning retaining the x values. So the x values remain the same, but the y value changes. So for the vertical stretch, we have the x values remaining the same, but the y value we have changing and the values are increased. So for this instance, if I have x equal -1, for the original function, I would have 1. But for the stretch graph, when x is -1, -1 square, so I will have +1, times 2. So that means on the new graph, I'll have x is negative 1 and y is 2. Let's take over here. When x is 1, y is positive 1. So I replace x to be 1 into the stretch curve. You realize it becomes 2. 1 squared is 1 times 2. That gives me 2. So just remember that the x values, they remain the same. However, we have the y values being changed. Let me look at another example. Here we have y equal x squared, and if I insert y equal 2x squared, as we can see, the graph is going inward. It's a vertical stretch. Let us look at y equal 3x squared. As you can see, it's being stretched more. So I have y equal 10x squared. Now looking at this, you can see that it's stretching. So what can I establish here? Well, what I can establish is that the y value is being affected by what is the value of a. And since a is greater than 1, it vertically stretches. Now, the x values remain the same, but as you can see, the graph gets steeper and steeper. So that is why we're able to see there's a vertical stretch. And what happened also is that the y values, as we stretch the graph, the y values get further and further away from the x-axis. That is why it's a vertical stretch, because the y values are getting further and further away. As a increases, it's getting further and further away from the x-axis. So the graph getting steeper, so this is a vertical stretch. Now the vertical compression, here we have a to be 0.5. What is happening is that the numbers, the y values are being decreasing. It's getting closer and closer to the x values. So it's like the curve is flattening and it's going towards the x-axis. For example, we have y equal x squared, and then I have y equal 0.5 x squared. You can see it's moving, getting closer and closer to the x-axis. It's like it's flattening. And we are able to see, okay, let's look at when x is negative 2 for the original, I get 4. But as you can see now, it's 2. So if I have 0.25, then I'm expecting it to get flatter, where y will be 1. So if I have y equal 0.25 x squared, as you can see now, x equal minus 2, I am having y equal 1. So it is getting closer, the y values are getting closer and closer to the x-axis. This is 0.1 x squared. As you can see, it's getting closer and closer. So the compression is where we're having the y values getting closer to the x-axis. Now, horizontal stretch or compression. Now, for the horizontal stretch or compression, it's y equal f of open bracket ax. We multiply x by a. And once you're doing that, it means the y will also change. For the horizontal stretch or compression, y equal f of ax, then what is happening here is that we multiply the x value by a first, then we substitute it into the function to get the new y value. So in general, when a is greater than 1, the curve horizontally compresses. And when a is greater than 0 but less than 1, the curve horizontally stretches. Now, the original function is y equal x squared. So if I have y equal 2x all squared, what happens? So at x equal 1 for the original function, I have y to be 1. But here, when I have x equal 1 and I put it into this function where a is 2, I will have 1 times 2 is 2 and 2 squared is 4. So for the compressed diagram, as we can see, it is now y to be 4. So x is still 1, but y is 4. If I choose another point, let's see over this side, I want to just find an exact number. So x is -1, I have y equal 1. So in the compressed diagram, I would have it to be 4. X is -1 and y is 4. Now what is happening here? What is happening is that we're compressing it towards the y-axis. That's what's happening here. So we're compressing it towards the y-axis. It's getting closer and closer to the y-axis. So whenever we have a to be greater than 1, we say we have a horizontal shrink. It's getting closer and closer to the y-axis. So we call it a horizontal shrink. So let's look at y equal x squared. If I go ahead and have y equal open bracket 2x all squared. As you can see, the graph is getting closer and closer to the y-axis, so we call it horizontal shrink. If I have, for example, y equal 3x all squared, as you can see, it's getting closer and closer to the y-axis, so y equal 10x all squared. It's getting closer and closer to the y-axis. Now, if I have, for example, a number between 0 and 1, then we get an horizontal stretch where it's get further and further away from the y-axis. So we call it a horizontal stretch. So for example, if I go ahead and graph this, y equal x squared, and then I go ahead and enter y equal 0.5 x squared, all squared. As you can see, it's getting further away from the y-axis, and we say it's a horizontal stretch. Let's get y equals 0.3 all square. It's getting flatter and flatter. So this is showing me what's happening when I have a horizontal stretch. Next, we have reflection in the x-axis. This happens when we have y equal minus f of x. The curve is reflected in the x-axis. But for example, this is x squared, so the dotted line represents x squared. If I put a minus sign in front of it, then if you realize it becomes a reflection of the above. So once you have a minus, there's a reflection in the x-axis. If we have the minus inside the function where we change the sign of the x values, that's what's happening, then there is a reflection in the y-axis. So if I have the function y equal x cubed, which is the blue line, then the reflection will be this, which is minus x all cubed will be this function that we have here. So there's a reflection on the y-axis. So if you realize this is x cubed, and then the reflection in the y-axis, so it changes its direction. So this becomes minus x cubed. Next, we have the modulus. The modulus here is where we change things to become positive. So once we have the curve, in this case, the curve reflected on the x-axis, but we could have had a line. So modulus means we no longer have negative values. So all of this represents the y values being negative. So this that I here am I following the line. This on this curve where I'm following represents a quadratic where below the x-axis these are negative y values. So once we modulus, then we change the direction of it. As you can see, we have the bend going upwards. So the red curve, so we have this, the shape. This represents the modulus of the quadratic. Thanks for watching, guys. Don't forget to like and subscribe to my channel. And if you have a question, you can leave it in the comments below. Have a great day.